So this is the full bridge converter, what we are using with the to check the output voltage with freewheeling diode, without freewheeling diode for RL load, and for R load without freewheeling diode. The input from this is the transformer, isolation transformer. Input is 230 volts. It is having the tappings. We select 30 volts tapping. 30 volts terminals are connected to the AC input of the module, and we have got the miniature circuit breaker. Then output of the miniature circuit breaker terminals are available. They will be connected to combination of T1 and T2 dash, T2 and T1 dash, and T1 dash cathode terminals are shorted. That will form the DC positive bus. T2 dash and T1 dash anode terminals are short circuited. That will form the negative bus of the DC bus, and load is connected between these two positive bus and negative bus. This is the freewheeling diode. Freewheeling diode is used when we connect an inductive load. This experiment is full bridge converter. Right. So we will have all the 4 thyristors connected in the bridge form. T1, T1 dash, T2, T2 dash. T1 and T1 dash will conduct together. T2 dash and T2 will conduct together. So we have got the input here, isolation transformer. Isolation transformer input has been given to the input of the module. Then we have got the circuit breaker. Circuit breaker output is given to the bridge center point, and then bridge output is taken and given to the load. And to monitor the load voltage, we have connected the digital multimeter, and we have got the pulse generation scheme. Right? In the pulse generation scheme, we get 4 pulses, one for T1, T1 dash, T2 and T2 dash. When we vary the firing angle, we get the output voltage varied. Now the firing angle is at 0. So the full wave is coming out at the output. This what I am monitoring here is the voltage across the load, right? And the multimeter shows the voltage out across the load, DC voltage. Now when I vary, you can notice that the firing angle is getting altered, and the conduction duration is getting reduced. So this much of portion of the voltage is cut off, not appearing across the load. So the DC voltage also starts getting reduced from previous value to, it has come down to 24. Now I further reduce the firing angle, right? Now it is around 60 degrees, right? When it is at 60 degrees, we are getting around 20.6 voltage across the, with the DC multimeter. Right, this is the waveform that we get. So we have to record these readings. That is, we have to note down the firing angle and observe the waveform, what change it is taking place, and what is the DC voltage that it is appearing across the load. That is what this experiment is. This I have connected a resistive load. So, same thing can be same experiment will be conducted with inductive load connected, right? And then R will come in series with the inductive load, and we can connect 150 millihenries in series with that. Then we can observe the waveform, right? Then we can this first we see without the freewheeling diode. Then we include the freewheeling diode and see what the changes in the waveform is going to be.